Spice Math. That's right. You add it up, multiply it, man. Spice Math. Okay. A couple things we're gonna learn today. Spice Math. All right. Take some time, educate yourself. Spice Math. That's right. You won't believe it's just math. Come on.
Hi, I'm Ruth Doughton.
Hi, I'm Aaron Williams.
Hi, I'm Brandon Alexander.
Hi, I'm Kelvin Doughton.
Hello, I'm Lyndon Sincere.
We are your Spice Math tutors.
You won't believe it's just math. Just math.
Hello again and welcome to Spice Math. Today we'll be looking at standard form and how we can express it in mathematics. And I'd like you to think back on some of the lessons we did previously with base 10. In today's lesson, you will be able to define what is standard form. At the end of the lesson, you will be able to explain the connection between standard form and base 10 numbers. And you'll also be able to write large and small numbers in standard form. What then is standard form? You will see a definition coming up on your screen, and it says, standard form is a way of writing numbers in two parts, including a power of 10. And generally, this can be expressed this way: a multiplied by 10 to the power of n for a line between 1 and just a little less than 10. We're going to look at some examples because standard form can be used especially when you have to express or write down very large numbers or very small numbers. We're going to look at some examples now and see if we could express them and find out what is the pattern that we see emerging from some of those. Example number 1. 230 is equal to 2.30 multiplied by 10 to the power of 2. If you look across the page, 7,801 is equal to 7.801 multiplied by 10 to the power of 4. The other examples, if you look carefully, you'd notice that in all the examples, in order to get standard form, we seem to be moving the point in a particular direction. That is the decimal point. Let's take number 1 for example. 230 is equal to 2.30 multiplied by 10 squared. On the left side, we have the number 230 in decimal form. On the right side, we have the same number, 230, but this time it's in standard form. And notice from the definition, it's written as the product of two numbers, 2.30 multiplied by 10 to the power of 2, otherwise known as 10 exponent 2. When we compare all the examples that you might be looking at on your screen, the pattern seems to be moving the point from its original place, as in the case of 230. The point would have been located immediately to the right of the 0 in 230. If we move the point backwards, we are going to get the 230 to look like the very first number in the result. And that first number is 2.3. So if we move the point 1, 2 places, it's now placed between the 2 and the 3. And the number of places that the point was moved is actually the number which represents the power of 10 in the result. So 230, if we move the point 2 places to the left, 230 will become 2.30 multiplied by 10 to the power of 2. If we look at the second example, let's see what's taking place there. 7,801, and that is equal to 7.801 multiplied by 10 to the 4. It's actually supposed to be 10 to the 3. Once again, we see the point being moved from its original position. That is, we had 7801. The point would have been located to the right after the last digit. And that point is moved back 1, 2, 3 places so that it falls between the 7 and the 8. And that happens to give us the first number in the result. So 7,801 is now equal to 7.801 multiplied by 10, and the power comes from the number of places the point was moved as we shifted the number from 7801 to 7.801. The point was moved 3 places, hence 10 to the power of 3. And that pattern can be observed from all the other examples you see on your screen. 78.56, the point was moved back 1 place to the left, so the power of 10 would have a 1 by it. 9.205, notice that the point didn't move at all in that one, so the correct answer is 9.205 multiplied 10 to the power of 0, which represents a movement of no places, or of 0 places. Let's look at the last 2 examples. 0.00394, and observe in this example, the point is now moving to the right. So we have 0.00394, and the correct answer for this is 3.94 multiplied by 10 to the negative 3. So once again, the point is moving, but the direction has changed. And this is what gives us the negative power of 10 because of the change in direction of the point. So let's see. If we want to get 3.94 from this number, we'd have to move the point 1, 2, 3 places so that it falls between the 3 and the 9. And because we moved the point to the right 3 places, the power of 10 would be negative 3. And if you look at the last example, 0.0000188, that is equal to 1.88 multiplied by 10 to the negative 5. How did we get the negative 5? By moving the point 1, 2, 3, 4 zeros, and then it's going to fall between the 1 and the 8. That would give us 5 places to the right. That's how we get the negative 5. We can therefore see that there is a pattern for converting a normal decimal number into standard form. And it's basically moving the point so that the first number would lie between greater than 1, but just less than 10. And if you look at your screen again, you will see in all the answers, the first number in all of the answers lies between 1, they're greater than 1, but they're all less than 10. So that's the pattern we observe. The next pattern that is observed is that if the point is moved to the left, the power of 10 is positive. And if the point is moved to the right, the power of 10 is negative. Okay, now that you've had these principles, let's see if you can try a few of these activities or a few of these problems. In this activity, you would have about 5 questions that you can go through, remembering what the steps are. You move the point until the first number is greater than 1 but less than 10. And the number of places you move the point would be that number placed as the power of 10. Then you have the direction. The power of 10 could be positive if you move the point to the left, and the power of 10 will be negative if you move the point to the right. So take some time, and we're going to come back to check to see if you got the correct answers for the activity you see on your screen. All right, welcome back. Let's check the answers for the activity you did. If you looked at the board, number 1, 714 is equal to 7.14 multiplied by 10 squared, because the point would have moved 2 places to the left. Hence, the power of 2 on the 10. Number 2, 10,052 is 1.0052 multiplied by 10 to the 4. Because the point moved 1, 2, 3, 4 places. Number 3, 3.57 multiplied by 10 to the 1. Number 4. You have to be careful here because this time the point moved 1, 2, 3 places to the right. So that means the power of 10 should be negative. The answer is 6.239 multiplied by 10 to the negative 3. And the final one, 0.917 is equal to 9.17 multiplied by 10 to the negative 1. So you can check your answers and do as many reviews as you can. I'd like to wish you all the best and every success as you practice your math. Thank you.
Spice math, that's right. You add it up, multiply, man, spice math. Okay. A couple things we're gonna learn today. Spice math. All right. Take some time, educate yourself. Spice math. That's right. You won't believe it's just math. Come on. You won't believe it's just math.